It's a pleasure and honor to welcome Professor Wang to Living Histories to tell us about living histories. Please take it away, Professor Wang.
Thank you for inviting me to share my personal story. I'm from NC State, and today I'm going to talk about career detours and heroes along the way. I grew up in a compound in China that was established by Canadian missionaries. And here I want to mention my first hero, Dr. Robert McClure. He was a missionary doctor in my hometown 100 years ago. He was the first doctor to use radium in cancer treatment in China. And he's my hero because he risked his life to serve the poorest people at that time. This is my picture visiting my childhood apartment 2 years ago. And I got interested in science because my father worked at the hospital left by Canadian missionaries. At that time, there were very few textbooks, very few other books to read. When he went on a trip, he would brought back this type of small books on scientists, Western scientists, Eastern scientists that got me interested in biology, got me interested in physics. This is a picture of me in elementary school. I should also say my high school teachers also got me well versed in science. I was from a small town, but my high school teachers are phenomenal. Still to this day, I still use the same method my high school teacher taught me to explain how to convert mass concentration to molar concentrations. And I went to Zhejiang University in Hangzhou to study material science. I should say that from very beginning to the very end, I totally lost because at that time, the textbook doesn't have why question and how questions. I lost confidence in my own abilities. But luckily, Zhejiang University is in Hangzhou. People say it is a heaven on earth. I spent a lot of time wandering in nature and amazed by bamboo and water lily I haven't seen before. Looking back, I think I was a student who lost my way with very poor GPA, but on the other hand, I was growing in another way. I still keep wondering about nature and amazed by nature. I moved to United States in 1998. At that time, at beginning, I was making carbon nanotubes. Quickly, I found that I couldn't be a good engineer. I couldn't make the nanotubes better. Luckily, I met my hero, Dorsey Erie, and he showed me the picture of protein DNA images. Immediately, I was amazed. I thought, oh, this is a system that is alive. It is different from nanotubes. I don't need to make it better. I just need to image it and absorb it. That's how I hooked onto FM imaging and got interested in DNA repair, how protein find mismatches or lesions in the C of undamaged DNA. These are images from my PhD study showing mismatch repair protein, mute-S, bend and unbent DNA. And I should say Dorsey really encouraged me to have my own voice. We work on manuscript together for many versions. And I should also mention that I had twin boys along my way. During my second year, I was pregnant and international office told me I should drop out of school. I couldn't be able to keep up with my study. I went to see Dorsey, almost crying, saying, I'm pregnant. Dorsey said, so what? And then I follow up by, I'm pregnant with twins. He quickly said, so what? So I was able to go back to lab even after 2 months of bed rest and managed to still get experiment done at night with the free UNC shuttle to the lab. I published 1 first author paper and 5 co-first author papers. during my PhD. I should say my twin boy were a bundle of joy. I think in some way it helped me. I was busy. I didn't have enough time to think about all the uncertainties in science. And I moved on to NIHS to continue my pursuit in DNA repair. I joined Dr. Van Houten's lab at NIHS. The only reason was it was 30 minutes away and it had the top rated daycare. That was the clear reason for me to join his lab. Ben was a great mentor. He always invited me to sit in all project discussions, and he made connection for me to give talks at conferences or departmental talks at universities. He made connection for me to establish my own collaborators. For example, he met David Bashaw at NIH panel meeting, and he connected me with his postdoc Neil Cat to start single molecule imaging project. At that time, I had been doing AFM for 5 years. I was wondering whether or not I could see the dynamic of protein and DNA interactions. Here, Neil and I co-developed an assay called DNA tightrope assay. We could label protein with quantum dot and see the dynamic behavior. Further, Ben made a connection for me to work with Patty Opresco, who is an expert on telomere biology. At that time, Ben asked me, Hong, what do you want to do after you finish your postdoc? I said, I don't know. He made a connection. I was able to use the DNA tightrope assay to study telomeres. These are the data from my lab at NC State. I was able to show that there are two different DNA recognition modes. For example, we all know TF1 is a dedicated telomere protein. It binds to telomeric regions. Here on the y-axis is the position, on the x-axis is the time. TF1 binds to the telomeric sequences stably. It's a dedicated telomere binding protein. On the other hand, if we look at cohesin, it pauses at telomeres only transiently. Then it will move on to other genomic regions. So cohesin is a gas at the telomere. For it to be function at the telomere, it needs other protein partners to stabilize it. Again, in this video, the y-axis is the position. We have DNA with alternating telomere and non-telomere regions. On the x-axis is the time progression. Recently, because our work with fluorescence imaging and AFM, more and more I realize our limitations. For AFM, we have static images. For fluorescent imaging, we have a dot. We know how fast it moves, where it pauses, but we don't know the shape of the protein, which part of the protein bind to DNA. Especially for multi-protein complexes like cohesin, it have multiple parts. This calls for a technique that can review the conformations of the protein, but also the dynamics. We started high-speed FM imaging. Here we have the protein and DNA in solution, images in real time, and we could see the protein with arms, and the arms can extend out, wrap onto the DNA. So that tells us the protein and DNA interaction can be through active forces from electrostatic forces between the DNA and protein. The protein can sense the DNA far away through electrostatic interactions. And I should say, looking back, these are the things I remind myself to stay grounded, to stay positive, especially in the current climate. Continue to seek out more mentors, multiple mentors, and expand the toolbox for research, connect with nature. That is how we get grounded. and connected with literature, poetry, especially from our own culture. Recently, I started to read more Chinese poems. That really helped me. I remember to smile every day. I enjoy the discovery process and keep the curiosity burning. That's what I want to tell, especially younger people. That's for all, I think, from my side.
Wow. Thank you, Professor Hong Wang,
Uh,
for sharing these insights and your living histories with us. We have a question from chat, which I'll ask first, um, which is, could you please discuss how you cultivated your mentorship team as you moved into your faculty career?
That's a good question. I already have great mentors. For example, Dorsey mentored me as an international student, didn't have my own voice, wasn't confident in speak out at meetings. She always say, you can do it. And for my team, I also cultivate their confidence, especially I think women in science. They came in a lot of time with imposter syndrome. I don't want to say women more likely or less likely, but I mentor more female students. I see imposter syndrome a lot. I have that too. I think the first step is to cultivate their confidence and make connections.
Wow, thank you. Which leads nicely to the next question I wanted to ask, which is related to the very relatable experience you shared from your early days when you went through a patch where your GPA dipped and you had to regain your confidence and find yourself again. Could you please share some of the things that helped you get out of that situation and get to the next stage successfully?
Mm. I should say I was lucky. I always had mentors along the way. There was a graduate student working with me. He really mentored me how to design experiments. Um, and through designing experiments, I see the logics in the scientific progression. That helped me to really gain confidence. I think a lot of times it's hard to do on our own, to get back on our feet alone. I think a lot of times seeking help from our peer, especially, is very important.
Thank you so much. On that note, I'm closing the recording.